Okay, because this concept of multiplying and dividing surds is fairly straightforward, today we're just going to do the last question on each of the bigger questions. So that means we're going to be doing X of question 1. So as we can see, we've got big numbers, big ugly numbers, so we're probably going to need to simplify them before or after. You can choose, but I would generally go after in this case because we want to practice our rules. So we can split these two into its two parts. So it's 3 times 2. We know we're going to have a total of 6, because remember we can split this up into 3 times root 48 times 2 times 12. Okay, in order of operations, they're all multiplication, so we can mix them up in any order. So in this case, I'm just mixing these two around in my head. So 3 times 2 is 6. Now I've got this 48 and the 12 to multiply together. So 48 times 12 is going to give me root 576. Now remember, you could have simplified these at the start, but we just want to make sure that we're practicing our rules, so we will do that. We'll do it this way for now. So root 576. Now what square number do we think that's going to go into? So because we've had 12 and 48, I'm going to take a guess and say 144. So 12 squared. So 576 divided by 144. And that gives me 4 straight away. So I've got 6 times root 144 times root 4. And because 144 times 4 gives me 576. Now, both of these roots should look pretty familiar, so I've got 6 times 12, because 12 squared is 144, and 2, because 2 squared equals 4. Now again, they're all the multiplications, so I can just go straight across and multiply them together. So 6 times 12 times 2 is going to give me 144. So that's my total answer right there. Okay, so on to the last sub-question of question 2 now, and as we can see, it's a similar format. They've given us a nice ugly number, so we're going to have to simplify either before or after. You can choose, but this time we've given a divide. Now they've chosen to give it in a bit of a funny way, so just remember that when you get this, it's exactly the same thing as writing it with an over bracket. We can split it up into its same parts if we wanted to. So we have 6 over 1, because remember there's an invisible 1 times out the front there. So 6 times 1 over 3 times root 243. Okay, we might need to change our strategy if this doesn't work, but hopefully 3 divided by 243, put that in your calculator, and then press your fraction button, and you should be able to get this as a simplified fraction. And my calculator, it says 1 over 81. So remember from our rule, this is now root 1 over 81. And as we should be able to see here, this can be written as root 1 over root 81. These should both look pretty familiar, as that is 1 and 9. So we can replace this whole thing here with 1 on 9. So we've replaced it with 1 on 9, and then once we do this, because we've got two fractions, when we multiply fractions, we just go straight across. So we then got 6 on 9. Now we can simplify this even further because they both have a common factor of 3. So 6 divided by 3 gives me 2, and 9 divided by 3 gives me 3. So our total answer is going to be 2 over 3. Okay, so moving on to question 3 now. As we can see, this one here is making use of a rule that we learnt earlier in the earlier exercises, which is this squared and root are opposite operations, so we can cancel them both out. So this first number here is the same thing as writing a. Okay, you can substitute a for something else if you don't understand. So let's just say we put 3 squared here. So what's this going to be? So 3 squared is 9, and then you're going to put your root 9, and as you can see, it still equals 3. And it's the same with any number. If you don't believe me, you can give it a try. Okay, so that first number there is going to be a, and we're going to be timesing that by root a. Okay, now can we simplify this down any further? So we have an a and we have a root a. Now, as we hopefully know here, that if we have an a and a root a, we can't do much about it, because if we have, for example, any number that is 3 root 3. Can we simplify this anymore? We could potentially do it if we wanted to use our index laws, which we will learn later. But we are not going to do that right now. Instead, we're just going to leave this in the form a root a, because remember, a root a is the same thing as a times root a. So in case you're interested in what we would do in case we really wanted to put it in this form, what this basically uses is our index laws. We will do them in another video. Basically, if you have the same base, you can add these powers when there's a multiplication. So in this case, 1 over 1 is the same as 2 over 2, right? Because they're both equal to 1. And then you can simply add that on, because now they've got the same denominator, to get 3. So you have 3 over 2 would be the power. So 3 to the power of 3 over 2. Okay, so I've moved on to question 6, just because questions 4 and 5 are multiple choice, and they're a bit boring, so we're going to skip them. Okay, and as we can see, we're doing now the last question of question 6. This is going to be the last question of this episode. So what we can see here is that we've been given one ugly root here, and it looks quite messy because you've got both divides and times in here. So what do we do when we have both divides and times? Well, remember from our bid mass, our order of operations, we do our brackets first, then we do our indices, then our divide and multiplications. So those orders don't matter, and then your additions and subtractions last. So because we have both divides and times, it doesn't matter which order you do them in. So we can stick with just going with our strategy from before, which is going to be pretending we have brackets up here and pretending we have brackets down here, and doing each the numerator and the denominator separately. So let's go through and simplify our numerator first. So we have 8 and then root 80. So what can we do to simplify root 80? Okay, so just taking a guess, I think that 16 is probably a good square number that would go into 80. So 80 divided by 16 gives me 5. So yes, it does go in. So root 80 can be rewritten as root 5 times root 16. Okay, so that's this number here. Okay, going on to our next one, this root 2 over here is a prime number, so that can't be simplified anymore. So we can just add this in to be our new numerator. Now, can this be simplified any more before we go and do our denominator? Yes, because remember, root 16 is the same thing as 4. So we have 8 times root 5, so that's the same as this, times 4, which is the same as this, times 3 times root 2, which is the same as this here. So we can treat this here as our new numerator. So what about our denominator? Do we have any ugly ones? So we don't really. We have 5 and we have 8. So 8 is a little bit ugly because I know that we can pull out another square number, which is going to be 4. So this 5 here is a prime number, so that needs to be left in its final form. So 4 times root 5, because it doesn't really have any other factors apart from itself and 1, times 6, and then this 8 here I know can be represented with the square number 4 and root 2, because remember 4 times 2 equals 8. So with that said, can we simplify this anymore? Yes, because root 4 is the same thing as 2. So let's go ahead and put this as our new denominator. Now the reason why I haven't gone through and times this 8, 4 and 3 together, or this 4, 6 and 2 together, is because sometimes you can get factors that you can just easily cross out. So if we have the same number on the top and the bottom, as I can see here with this root 5, it's going to cancel out with this 1 on the bottom. Now the reason why that is because we can rewrite this whole thing as root 5 on root 5 times the remainder of these. So 8 times 4 times 3 times root 2 over 4 times 6 times 2 times root 2. So if we times them together, it would be the exact same thing. And that's why we're allowed to take this out, because this is the same thing as timesing it by 1. So keeping that in mind, we look out for any more that we might be able to cross out. And what's this? Yes, I can see that there is a 2 and a root 2 and a root 2 there. So I'm going to cross those two out as well using the same logic. And then with these other two here, I could cross out this 8 and put, let's just say, a 2 and a 1 here. But I think the easiest thing to do in this situation would be then to times it all through, just so I can get a nice clean answer. So 8 times 4 times 3 is going to give me 96. And 4 times 6 times 2 is going to give me 48. So because I've gotten rid of my roots, I don't need to worry about them. So what is this? This can be simplified even further. So remember, we can use our fraction button in our calculator. If we go 96 divided by 48, we get 2. So if that had been a decimal, we could have pressed our fraction button, but we can see that's 2. So that's what our final answer is going to be.